Hello lecturers, in this video I will be doing basic static analysis on the malware that I have chosen. So first, we will be scanning the malware in VirusTotal to determine its detection ratio as well as the type of malware that we are dealing with. After that, we will head into the virtual machine where we will hash the malware with WinMD5 to obtain the hash value. Then after that, we will check if the malware is unpacked with PEID. If it is a packed malware, then the malware cannot be analyzed as most of its functions are hidden from view. After that, we will look up certain information of the malware that will be useful to us, such as its administrative information, its DLLs and their imported functions, as well as their strings. So firstly, we'll go into VirusTotal, and as you see, we have input the hash inside the search bar. Okay, now we'll search, and as you can see from the detection ratio, you can see that it has a 31 out of 52 detection rate, and that means that 31 out of 52 antivirus scanners have deemed the file as malicious. And further inspection would help us to prove that the malware is indeed a Trojan malware. As you can see from all the antivirus scanners, you can see Trojan in almost every one of them. So now we can head into our virtual machine right here, and we can start performing basic static analysis. So first up, we will be going to WinMD5, and this will actually help us to gather a hash value of the malware that we are dealing with. Okay, so now as you can see, the software has produced a hash value 9330DDD, so on and so forth, which is the hash value that we used to enter into VirusTotal earlier on. Okay, so that's the hash value, and it will also provide information on the size of the malware. In this case, it's 69,152 bytes. So after that is done, we will now head into PEID. And what PEID does is that it will help us to prove whether the malware that we are expecting is packed or unpacked. A packed malware, as I said earlier, has its most important functions hidden from view within the sight of the analyst, so it will be of no use to us. So in order to check, we have to run the malware inside here, inside PEID, and as you can see in the EP section, you can immediately see that it is a .text and it does not say like some sort of packer like UPX, the ultimate packer for executables, and we can actually gain information from this that it is in fact a .text type of file. Okay, further inspection would show us that it is compiled using LCC, which is called either local or little c compiler. So that probably means that the malware was compiled using the C programming language, and that the malware author used the C programming language to program this malware. So that really helps us to prove that the malware is unpacked, and we can further analyze it. Next up, we will use PEView. And this will help us to view the administrative information of the malware. There are tons of information here, but what we will be looking at would be image file header, and we'll be looking at the time date stamp of the malware. So this malware simply tells us that when the malware was last compiled and hence created. So we can see that it was last compiled on the 3rd of November 2003. So it has been a long time since the malware has been created 13 years ago. So that gives us information on when the malware was created, and certainly it was a long time ago, so there probably is a defense solution for it by now. It's a very old malware. Okay, so next we will head into dependency walker, and we will open up the malware. Okay, so from what we can see, the malware has 4 DLLs that it requires to run: shell 32, kernel 32, user 32, and the CRT DLL. And each of these DLLs have certain functions that make them unique. Okay, if we can see here in kernel 32, we can see a function called create file and write file, and these two determine that the malware manipulates files or creates its own file in order to harm the user's computer. Okay, so we got user 32, and then we got CRTDLL has its own functions, and this can help us further analyze the malware. And this also proves that the malware is certainly unpacked, as we can clearly see all of its functions and DLLs. Okay, so lastly, we'll be heading into bin text, and we'll run the malware, and this will display a ton of random strings which are completely useless to us. So what we want to find are strings that will be helpful to our analysis. So by clicking text here, we can see that immediately at the top of the screen, you can see all the functions and DLLs that we saw earlier in dependency walker that are also displayed here in bin text. The CRT, user, kernel, shell 32, and all of their functions are all here, which further instates that these functions are being used by the malware, and it's not just a lie. Okay, so further down, since we have already seen all these functions, further down I have examined two other types of functions that the malware most likely uses, which is get prop address, which is getting the process address, and also loading the library. So these strings can certainly help in our analysis, as we can research on it further and then hence prove what kind of malware we are dealing with. So with that, I conclude my video on basic static analysis, and thank you for watching.